episode where we shall look at the proposed kind of scope for the mathematics paper 1 of grade 11, 2024. Okay, so just like in the past, whereby any paper can have between 9 to 11 or 12 questions, depending on what the examiners were basically looking at or they were looking forward to testing. So I'll use an example of this past paper, and we shall see how to approach some questions, which concepts to add in, and basically as we prepare for our final examination. Okay, so question number 1, which is always the algebra. I'd always advise learners that this question should be your full mark question. In other words, you should be able to get most of the marks under this question. Okay. So for the first part where they ask you to solve for x, okay? So when you're solving for x in grade 11, we are basically using the factors and using the quadratic formula in most cases, okay? So for the first part where they tell us to solve for x, we have a quadratic, x squared minus 5x minus 6 is equal to 0. So I can get the factors. In that case, I'll have x minus, it's not minus 3. It's going to be x minus 6. And then probably x plus 1 is equal to 0. Okay. If I open this up, I'll get this whole thing then, which means x is a 6 or x is a negative 1. So we get these final answers by equating each bracket to 0, like x minus 6 is equal to 0, and then x plus 1 is equal to 0, and then we solve these equations on their own. So that is what we would get, okay, for the 3 marks. Alternatively, if you're having issues with finding factors, you can still use the quadratic formula with the a being 1, the b being negative 5, and then the c being negative 6. You'll still end up with the same answer. 1.1.2, we have 2 brackets being equated to 9. So in this case, we cannot use the dot product of saying 2x minus 3 is equal to 9 or x plus 1 is equal to 9. That only works if this was a 0. So what we're going to do here, we just have to open up these brackets, okay? So that's going to be 2x and x, that's going to be 2x squared. This and that is a 2x, and the negative 3 and that, I'm getting negative 3x. Negative 3 and 1 is a negative 3. Let me move the 9 that side, and then equate everything to 0. Let me collect the like terms and simplify. So that's 2x squared minus x. This and this is minus 12 is equal to 0. So let's see. Are we able to find factors for this? Let me do it this side. 2x squared minus x. And then we say minus 12. Will it work? Will it not work? Okay, let's see. So if this is a 2x and this is x, for me to get 12, I use a 3 and a 4. That's going to give me issues. Okay. I use 6 and 2. That is also extra issues. So rather than wasting time here, let me just use the quadratic formula straight away. Okay. So my a is a 2, my b is negative 1, and then my c is negative 12. Then if we have to substitute this into the quadratic formula, negative b plus minus the square root of b squared minus 4ac over 2a. So that's a negative and negative 1. Plus minus square root of negative 1 squared minus 4. The b is negative, no, the a is a 2. And then the c is a negative 12. This is all divided by 2 multiplied by 2. Okay. So all that is left is just for us to punch this into our calculators. Okay. So we're saying square root of that 4 by 2 by 12 over that. Okay, so the first answer that I'm getting is 2,71. Or the other answer that I'll end up with, if I change the sign to minus, is going to be negative 2,21. Okay, so those are the two answers that I'll get. So the factors were not going to work in this case. So this question usually comes with a condition that you must give your answers to 2 decimal places. All right, 1.1.3, where we have the third form, or the third, it's x minus, okay, the square root of x minus 1, okay, and then this is equal to 3. Okay, so if this is our question, step number 1, always isolate the root sign. In other words, let the root sign be on its own. Anything that is surrounding the root sign with a plus or a minus must move to the other side of the equal signs. So I have this x as an extra. I have to move it outside. Alternatively, you can move this root to that side and then move the 3 to that side. Okay. So in this case, I'm going to have negative x minus 1 is equal to, you can say 3 minus x. Or we said you can move the 3 that side and then the root that side so that you have x minus 3 is equal to the root of x minus 1. So either way, you still get the same thing. Then step number 2 is where we square both sides so that we can get rid of the root sign. So square there and then square that. Now, if ever, let's say there was a number in front of the root sign, this number would be affected with the square. It would be affected by that, okay? But in this case, there is no number there, so I don't need to include it there. So that's going to be the negative square will give us a positive, and then the root sign falls away. We have x minus 1. Then opening this side, it's going to be like a square bracket, x3 minus x, and then 3 minus x. Then we open this up using the FOIL. So that's going to be a 9 minus 6x plus x squared. And then from there, let's create a standard equation by moving everything to one side. That's going to be x squared minus 7x plus 10 is equal to 0. Then we need to solve this. I can use my factors. So x and x, I can use 5 and 2 and the minus minus. That will give me the negative 7 and then the positive 10. So either x is going to be a 5 or x is going to be a 2. All right. Then the last step is for you to test these numbers of yours to find which one satisfies the original expression. Many times learners forget about the testing pattern. They lose the last mark. Okay, so let me start with a 5. So if I get the 5 minus, we know that square root of 5 minus 1, that's going to be a 4. And we know that square root of 4 is 2. So 5 minus 2 is a 3, which means this is correct. Let's try a 2. If you have a 2 minus, what is 2 minus 1? That's 1. Square root of 1 is 1. When we subtract this, it doesn't give us a 3. So we cancel this out, or we can say it's not a solution. No solution for this. Or some people say not applicable. So whichever format you show us, but for as long as you cancel this out to tell us that it's not part of the solution set, then you'll have your full marks. Usually it's 5 marks. Usually it's 5 marks. Then 1.1.4, which is the inequality. So still, this other side is not a 0, so we have to open up. So that's going to be x squared plus 10x. Let's move the 25. That side, which will be plus 25, is greater than 0. Then let's factor that. So we said x squared plus 10x plus 25 is greater than 0. So opening this up, we can have x plus 5 and then x plus 5. That's what I'm seeing. Because that's a 10x, that's a 25. So which means in this case, we're going to have an equal root, which means the critical value is just a negative 5. Okay. Critical value is just a negative 5. Now, since we have our critical values, we need to represent this, okay? So in a case, let's say if we had two values, let's say x is A or x is C. Let's take A to be the smallest value and then C to be the biggest value. So the solution will be represented as x being less than the smallest value or x being greater than the biggest value if we had two values in this case. But then in our case, we only have one value. So what we're going to say is that we can have all values of x that are less than -5 or all values of x that are greater than -5 since it is just an equal root. Alternatively, you can tell us x is an element of real numbers. X should never be a -5. So that is also another alternative. If that doesn't work, you can also draw the number line. Okay, so if that's a -5, then you put your arrows there, moving in the right direction and then the left direction. If you're drawing parabolas, then that parabola must be touching just one point. You can put an opening to show that it's not inclusive within the solution set. And then you shed off that, and then you shed off that. Okay, so those are the ways in which we can represent the solution. So in this format, we have this format, or you can use that format, whichever one you feel comfortable with. Then 1.2, they want us to solve the equation simultaneously. So in this case, 1, we shall have a linear equation, which is this case, call it equation 1, and then we shall have a quadratic one, which is equation number 2. All right. So start with the linear equation and make something the subject. So I'm going to move y to the right-hand side, move the 1 to the left, which means y is equal to 2x minus 1. This I'm going to call equation number 3. Then it is this equation number 3 that we need to substitute into this first equation, the second equation, sorry. So it's going to be 3x squared minus 4x, where there is y, put 2x minus 1, and then plus 2x minus 1, but squared is equal to 0. Let me jot it aside. So we're saying it's 3x squared, okay, minus 4x into 2x minus 1, okay, and then plus 2x minus 1, everything is squared, is equal to 0. So we just need to open this up and then solve for x since we have just one variable. So 3x squared minus, that's going to be 8x, please, squared. And this -4 and the -1 must give us a positive 4x. And then opening this up, we shall have 4x squared minus 4x plus 1 is equal to 0. Then we need to collect the like terms, this, and that. So 3 and 4 is a 7 minus 8, that's -x squared. This 4 and that 4 will cancel out. Beautiful. Plus 1 is equal to 0. This is a difference of two squares. So it's the same as 1 minus x, and then 1 plus x is equal to 0. So if I reverse it around, it will be 1 minus x squared is equal to 0, and then I'll use the difference of two squares. So if I focus on this bracket is going to give me x as a positive 1. And then this bracket is going to give me x as a -1. Then having obtained that, I just need to substitute that into the y value. Remember, we said y was 2x minus 1. Okay. So if it is a 2x minus 1, you don't need to show us a substitution. You can even do it by your calculator. So 2 times 1 is 2 minus 1 is a 1. If I use a negative, it's going to be 2 times -1 is -2 minus 1. I'll end up with a -3. So those will be the solutions, and then you'll get 6 marks just for that. Okay, so that is how a question on simultaneous could be asked, okay? Sometimes they can give you such, and then they ask for the ratio of probably x to y or m to n and so on and so forth. It's just the same approach. 1.3, if x is -3 plus minus 2 root 2 are the roots of a quadratic function, f of x of which the y-intercept is 4, determine the f of x. All right, so we have -3 plus minus square root of 2. That is 2 root 2. Okay, those are the solutions. Then they want us to get the function itself. We have the y-intercept whereby x is a 0, and then y is a 4. So what we can do is we can use the intercept approach, which is a into x minus x1 into x minus x2, where x1 and x2 are the roots. Okay, so I'll say y is equal to a into x. We replace this. It's going to be minus, this is -3. Let me use a plus, 2 root 2 into x minus -3 minus 2 root 2. Okay. We can open this up before we do the substitution later on. So a into x, that's going to be a +3. Then this and this is -2 root 2 into x, that's going to be +3. And then that's going to be a +2 root 2. Then at this point of 0 and 4, let's replace x with a 0 and then y with a 4 so that we can obtain our value of a. So 4 is equal to, that's a 0, that's a 0. So 3 minus 2 root 2. Okay, multiplied by 3 plus 2 root 2. That gives me a 1. Okay, if I use my difference of 2 squares, that's my 1a. So which means a is a 4. Then I just have to substitute that. So 4 into x plus 3 minus 2 root 2 into x plus 3 plus 2 root 2. We could leave it like this. I mean, they never said they want it in which other form. Had it been that it was x squared plus bx plus c, yes, we would have gone ahead to do that. But if people want to do that, yes, we can do that. Okay, so that's a 4 into x and x, that's going to be x squared. This and that is going to be a plus 3x. That and that's going to be 2 root 2x. Then plus this and that is a 3x. This and that is a 9. This and that is going to be a 6 root 2. Then lastly, we have this and that, which is going to be minus 2 root 2x. This and that. Let me just erase this plus sign. Okay, so we're saying root 2x. And that's going to be minus 6 root 2. This and this is going to give us minus 4 root 2. So let's cancel what needs to be cancelled. So we're seeing the plus 2 root 2 and the minus 2 root 2. We're seeing a plus 6 root 2 and then a minus 6 root 2. Then this and that can combine up. All right. So it's a 4 into x squared plus 6x. And then I have minus 4 root 2. Opening up, we have 4x squared plus a 24x minus 16 root 2. So that becomes our f of x. That is our f of x. But does it make sense? If x is 0, and then y is a 4, does it make sense? No, it doesn't make sense. It doesn't make sense. It doesn't make sense because this is a root 2 and the root 2. So this and that is a 2. It's a 4 times 2. So that's going to give us negative 8. That's going to give us a negative 8. Okay, so this should be -8. Okay, because that's a 2 -8, and then that's a -32. All right, so that is what would be our answer in that case. Okay. Then now we move on. Question number 2. They want us to simplify. So we have exponents. So whenever you have exponents, try as much as you can to create simpler bases, okay? Let's create the simpler bases. And in this case, we can use bases of 2 and 3. So that's going to be 2 cubed into n minus 3. We know 32 is going to be 2 to the exponent of 5 into -n plus 1. And then 6 can be 3 and 2. So 3 to the 2n, and then 2 to the 2n. They will share the same exponent. 9 is 3 squared, which is 3 that. Okay, so I can already see that this can cancel that. And then all I'm left with is just numbers with the same bases, and I'll have to add up the exponents. All right, so the base is 2. That's going to be 3n minus 9. This is 5n plus 5, and then that's 2n. We are adding a 2n. Okay, then this is a -5, so it's -5n. Okay, so this is a -5n. Okay, so we know that 2 plus 3 is going to give us a 5. And then when you subtract the 5n, those n's will go. We're just left with -9 and +5. So it's a 2 to the -4. When we simplify that, it will be 1 over 2 to the 4, which is 1 over 16. So that is how that question would be approached. So it's all about applying just the laws of exponents, okay? So sometimes if that is brought in form of the square root, remember square root is just exponent a half. If it's a cube root, it is exponent 1 over 3, and so on and so forth. Then 2.2, they want us to solve for x, okay? We have this to the exponent of 2 over 3 is equal to 4. So if you have an exponent that you need to get rid of, we normally use the reciprocal. Okay, so if that is 2 over 3, the reciprocal of 2 over 3 is 3 over 2. Okay, so let me make 4 the base of 2. Okay, so times 3 over 2 times 3 over 2. So this will cancel out, and then you have just a plain x, okay? These 2 can cancel that 2, you'll be left with just 2 cubed. And then 2 cubed is the same as 8. So which means our x value is 8. So show us how you're applying the reciprocal, and then well and good. Alternatively, this question would have also been asked as the cube root of 3 is equal to 4. So what somebody would have done is you cube both sides, and then you apply the square root afterwards. All right, then 2.2.2. 2.2.2, we have this 2 to the 2x minus 4 to the x minus 1 is equal to 12. So let's create the same base, especially for this 4. So that's going to be 2 to the 2x. Okay. Remember, we're saying 2 to the 2x minus 4 to the x minus 1. And then we're saying we're equating that to 12. So that will be 2 to the 2x minus, that's going to be 2 squared. Then we have x minus 1 is equal to, let me keep the 12. Let me keep the 12. Then if you try to expand that, it's going to be 2 to the 2x. That's going to be 2 to the 2x multiplied by 2 to the negative 2. Okay, is equal to 12. Let's factor out what is common, which is 2 to the 2x. And then I'll be left with 1 minus, we know that 2 to the negative 2 is just 1 over 4 is equal to 12. Then what I can notice is that 2 to the 2x can stay there. When I apply this in my calculator, that's going to be 3 over 4 is equal to 12. Then I'll divide both sides by 3 over 4. I'll divide by 3 over 4. So that cancels that. 2 to the x, this must give me a 16. Okay. So 2 to the plus 2x. I don't know why I'm keeping x now. Okay, 2 to the 2x is equal to 2 to the exponent of 4. Then drop the bases, and then we have 2x is equal to 4. Divide both sides by 2, which means x becomes a 2. So we are done solving that. Alternatively, you can let your 2 to the x be maybe a k, then use the k method for that particular aspect. 2.3, if we are given g of x is equal to x squared minus 2x plus 2 over 3 minus x, determine the values of x for which this is not defined. So not defined is the same as undefined. And we know that something can be undefined if the denominator, okay, if the denominator is a 0. So equate the denominator, which is 3 minus x is equal to 0. Solve for x. So if ever x is a 3, the whole expression is going to be undefined. All right. Then 2.3.2, explain why the g of x will never be equal to 0. Okay, so why can this expression be never be equal to 0? So they are indirectly asking us to solve. Okay, why it can never be equal to 0. So which means it can either be less than 0 or greater than 0. So the explanation could be simple, just factorize what is on top. Is that even factorizable? Is that factorizable? Now you can try to do the substitution and say if x is equal to 0. Okay, so you can have a 0 at the top, and then you'll have a 2 extra over 3 minus 0, which will give us a 3. So in other words, we shall always have this 2 over 3 as an extra, and that 2 over 3 is greater than 0. Therefore, the expression can never be equal to 0. Had it been that after the substitution of x with a 0, we get a 0, then definitely this would be contradicting to what the statement is saying. So that is question number 2. Question number 3, which is the number patterns. So with number patterns, you just need to familiarize yourselves with 1, the linear patterns or the arithmetic, and then 2, we need to know about the quadratic patterns. Just that. Okay, so mark allocation for this question is always sweet, probably 20. Yeah, 20. So 25 plus minus there. So if we have this, that we are given a sequence of 10, 7, 4, and 3, they want us to write down the next terms of the sequence. So we don't know whether it's a quadratic or a linear. Let's see. So we are subtracting 3. We subtracted 3. We subtracted 3, which means we go on subtracting 3's. So 1 minus 3, we're going to get a negative 2. We subtracted 3, we get a negative 5. Then determine the nth term. So nth term can be obtained by getting this common difference, which is negative 3n. Okay. Then get 10, which is the first term, minus the common difference. So 10 minus 3, I'll get a plus 13. So that is my nth term, or the rule. Okay. Nth term is like a rule or the general term. Then which term in the sequence is equal to negative 179? So where there is Tn, because this is our Tn, let's replace it with negative 179. So 179 is equal to negative 3n plus a 13. Okay, let's move the 13 that side, which means it's going to be 179 plus 13, which gives us 192. Okay, but the 192 is negative, is equal to negative 3n. And then if we divide this by 3, our n is going to be just the 64. So which means the 64th term is the one that is equivalent to negative 179. All right, then 3.2, we are given the first 3 terms of a linear sequence using unknowns. Can we determine the value of x? So the trick around this question lies within just the common difference. So even if we have unknowns, the common difference must still stay the same. Let's see. So if I get this t2 minus the t1, okay? So I'll have x plus 9, okay? X plus 9 minus my t1, which is 3x minus 2. Please apply some brackets there. You will thank me later. Then this is 2x plus 5. Okay, 2x plus 5, you subtract this whole thing, x plus 9. Reason as to why we apply the brackets, because the whole term is affected by the negative sign. Let's open up that. So x plus 9 minus 3x plus 2 is equal to x plus 5 minus x minus 9. We know that d1 must be the same as d2. Simplify this, negative 2x plus 11 is equal to x minus 4. Then now we know that negative 2x minus x, that's going to be negative 3x. Negative 4 minus 11, that's going to be negative 15. Divide both sides by negative 3, which means x is a positive 5. So that is how we would have obtained that. All right. Then question number 4, we have the quadratic. What we need to know about the quadratic is that we have 2 differences, the first difference and then the second difference that must be constant. So let's have negative 128. Okay. Then we have, let me just take this out. Okay, so negative 128. Then we have negative 84. Then we have negative 48. And then we have negative 20. All right, then they want us to get the next 2 terms of the pattern. So for you to get the 2 terms of the pattern, try to investigate how the pattern is moving on, okay? So for me to get what they're subtracting, get this negative 84, you subtract the negative 1 to 8. So negative 84 minus that, which means they are adding a 44. And then that, I'll do the same thing. Negative 48, I subtract negative 84. We are adding a 36. And then what's happening there? Negative 20, I subtract that. I'm having a 28. So what's going on here? I'm seeing it's also a decrease in this case. So it's 36 minus 44, which means it's a minus 8. And then if we subtract 8 there, 28 minus 36 is also a negative 8. So which means if we subtract 8 there, that's going to be a 20. Okay, so negative 20 plus 20 is a 0. If we subtract 8, we're going to get a 12. Because 20 minus 8 is a 12. And then 0 plus 12 shall have a 12. So it's an increasing quadratic pattern. So those would be the next 2 terms. Then determine the general term. So with general term, what we always do is this is always equated to A. This is equated to 3A plus B. And then the first term is equated to A plus B plus C. All right, let's see if we do that. We approach it in that format. So 2A is negative 8. Divide both sides by 2, which means A is negative 4. Then 3A plus B is equal to 44. So where there is A, we replace this answer of ours. So that's going to be negative 12 plus b is a 44. Let's move the b, the 12 that side. That's going to be 56. Then a plus b plus c must give us negative 128. But our a was in negative 4. Our b is a 56. We're looking for c. Okay. So if I do the magic, that's negative 128. I'm going to move everything that side. I'll be left with a negative 52. All right. So 128 and 52 combined, I'm getting 180. So my c is negative 180. So therefore, the Tn must be negative 4n squared plus 56n minus 180. All right. Negative 4n squared plus 56 minus 1. Okay. Given that Tn is that, which confirms the answer we got there, they want us to get the biggest numerical value of Tn. So this question is common, okay? They may not ask the biggest or the smallest. Sometimes they can ask for maximum and minimum. Remember, this is a quadratic pattern, which quadratic pattern forms a parabola. So if we were to sketch this parabola, it's a frowning parabola, which means it has a maximum somewhere, or which is the biggest number. So for us to get the biggest number, use the x is equal to negative b over 2a. Okay, so that's negative 56 over 2 times negative 4. So where do we find the biggest number? It's at a point where x is a 7. Okay, so if x is a 7, then we shall have our biggest number. But in this case, since our variable is n, then I think it's better if we stick to n. Okay, term number 7 is going to be the biggest. So let's substitute that. T7 is negative 4 into 7 squared plus 56 into 7 minus 180. So negative 4, we're saying 7 squared plus 56 times 7 minus 180. So we're seeing that the biggest number that we can ever have is going to be a 16. All right, so that is what is happening with that. Then 4.4, given that h of n is a Tn plus k, for which values of k will Tn not have any positive values? For which values of k? So this k is just an increase, which means it's a shift of the graph vertically, upwards and downwards, whereby we shouldn't have that to be a positive. In other words, the intercepts should just be negative. Okay, so looking at this question for 2 marks, it makes me wonder. Remember, our maximum we got was 16. So for it not to have any positive values, because we don't know where the function is cutting the axis, okay? But we can see that, okay, if I try to solve this, I'll have n squared minus 14n plus a 45 is equal to 0. Okay, if I try to solve this, it's going to be n minus 9, n minus 5, which means that both values are positive. Okay, when n is 9 and when n is 5, that's where the graph is cutting. Okay, so if that's a 5 and then that's a 9. So when does it happen that doesn't have any positive values? I think that's when it is below. So which means k. So we're getting the k, which with the 180, so negative 180 plus k. But we said our maximum was a 16. I don't need to even use the 180. Doesn't help. Okay. So which means I need to move this value downwards. So k must be less than 16. So in that way, we're not going to have any positive numbers. All right, so that is question number 4, which is the quadratic. Question number 5. Good people, please and please and please, whenever you see such questions of functions, do not skip, especially if it's a hyperbola. They're telling us that f of x is negative 3 over x plus 3 minus 1, and then g of x is negative a to the x. There is a point 1 and negative 3 that lies on g. Let's take note of that. Can we determine the values of a? It's value a. So with this, since we have just one unknown a, which means one point is just enough. So where there is x, we replace with a 1. Where there is y, we put a negative 3. So that's going to be negative 3 is equal to a to the positive 1. Anything to the exponent of 1 is always the same thing, which means a is going to be negative 3. So it all relies on substitution if you have an exponential somewhere. Then write down the asymptotes of f. So asymptotes of f, remember we have 2 asymptotes for this graph because this is a hyperbola. Okay, we have what we call the horizontal and the vertical. So for us to get the vertical asymptote for the x, come to the denominator here. Okay, the number that is given here, just change the sign. Now this is a plus 3. Then we're going to have just a negative 3. Then the other asymptote of y, let's get whatever we have there, and then that becomes the asymptote. If it's a positive number, then just write the way it is. If it's a negative, then write the way it is. So y is negative 1, x is negative 3. Those are the asymptotes. Then when they ask for the range refers to the y values. Some people call them the output values. So for output values of g, remember g is exponential, whose asymptote is a 0. There's no asymptote. It's just x being a 0, that line where y is a 0. Okay, so if that is the case, which means the graph must be greater than all those values. In other words, it must be above 0. So all values of y that are greater than 0, the graph will exist. Okay, then determine the x and y intercept of f. Why are they giving us 3 marks? Should be 4. Okay, so we're saying negative 3, x plus 3 minus 1. That is f. All right. All right, but remember f of x is the same as y. So we know that for x intercept, this is the biggest one, y must be 0. So 0 is equal to that whole thing, and then let's move this one first. Okay, so if the 1 is moved, then it's 1 is equal to negative 3 over x plus 3. Then cross multiply. So x plus 3 is equal to negative 3. When you move the 3 that side, then x becomes a negative 6. Then for us to get the y-intercept, okay, x has to be a 0. So you can even do this with a calculator. Replace x with a 0, you have negative 3 over 3, which is negative 1. You minus 1, then we're going to have negative 2. So if x is 0, y is negative 2. If x is negative 6, y is a 0. And then neat sketch of f and g. Wow, sweet, 6 marks. We must indicate the asymptotes and the intercepts. Now, what I usually advise people is that you don't need to be perfect for you to get all the marks of sketching a graph, because there are certain aspects that we look at. We don't look at your coordinates and everything on. Step number 1, if I'm to sketch, let's say, this hyperbola, my first thing that I should look out for will be the asymptotes. Let's indicate the asymptotes. So we said x is negative 3. So along the negative 3, maybe if this is my negative 3, then we said y must be negative 1, which can be slightly there. Okay, so draw those asymptotes. So I'm going to draw those asymptotes using this magic color. Okay, so just use dotted lines. You leave out the asymptotes, you're going to lose some marks. Okay, indicate that with just a dotted line with a ruler. So that is done. Probably that's a mark. Then we need to find the asymptote, no, the intercepts. So we said with the intercepts that -6 goes with 0. Okay, so -6 and a 0 can be, that's a 3. This can be -6. Okay, then we said 0 is going with what? -2. 0 with -2, which can be somewhere there. Mind you, I'm just sketching. I'm just putting the points there. Then, those are the only points I have. Now, how do I come up with the graph? So, in this case, you need to know the knowledge of how does the hyperbola look like. Okay, so you know that a hyperbola is just a graph in 2 quadrants, okay? It can be in the first and the third, or it can be in the second and the fourth. Now, if the number on top here is a negative, which means your graph must be in the second and the fourth. So in other words, if the A is less than 0, you're looking at quadrant 2 and then quadrant 4. If that number is positive, then you look at quadrant 1 and quadrant number 3. Okay, with quadrants, we are referring to the quadrants that are created by their asymptotes. So since the graph is cutting this point, which means I'm going to have a graph in this sort of format. Yes, this is misleading because it looks like it's going to touch the asymptote there. This graph should not touch the asymptotes. Okay, and in this case, it should just move from that point, make sure it cuts the intercept, and then just move downwards. So we call this our F, not a G. So this is the F. So we have roundabout maybe 4 marks just for sketching this hyperbola. Okay, so what we look out for, this intercept, that intercept, the asymptotes, as well as the shape. Did you put them in the correct quadrants? Do the graphs look like really hyperbolas? Don't draw straight lines in that case. Then for the exponential, we know that the shape of an exponential is something like that, or something like that. So since the A is a negative, this might actually even change the whole scenario of this range of hours. Why is it greater than 0 if it's a negative? Anyway, let's see. So if X is a 0, okay, so we're saying if X is a 0, Y is going to be, remember it is negative. There was a negative here, which means the X is a 3. Then this is a 0. Okay, so if X is a 0, so it's like -3 to the X. Is that so? Because we said A is a 3. Yeah. Okay, so if X is a 0, Y is going to be -1. Let me use a different color. Then if X is a 2, Y a 2, let's use a 3. If X is a 3, Y even a 3, just a 1, positive 1. If X is a 1, Y is -3. -3, somewhere there. If X is a 2, then you have a negative. So which means we just move in this sort of direction. Okay, that's why I said it will change our range. So which means Y must be less than 0. In that case, I'm sorry I didn't notice that sign up there. Okay, then we've drawn our graphs. Then 5.6, determine the axis of symmetry that has a positive gradient. So axis of symmetry will always be given as X plus C. Okay, It's positive or negative. Now, since our interest is a positive, so it's just x plus c. Then for us to get the c value, use the asymptotes. So the asymptotes are -3 and -1. Okay, y is -1, x is -3. Move the -3 that side, c becomes a 2. So which means it's x plus a 2. All right, then 5.7, if it's given that h of x is f of x plus b, they want us to determine the value of b such that the range of f is not equal to 0. Okay, so this b is just a shift. In other words, we are shifting the hyperbola. Okay, so that the y is an asymptote at the x-axis here. Because y is equal to 0 will be an asymptote. So how many units must we move the graph? So it has to be a positive 1. Because you're moving the graph 1 unit upwards. So determine the value. So b must be a 1. All right, so that is question number 5. Question number 6, parabola and a straight line. So r is -1 and 9 is the turning point. Okay. Of this graph, P, Q are the x-intercepts of F, TV is a straight line that is parallel, G of x, we have it, has the x-intercept as P, S is a point of intersection, good. Then they want us to get the coordinates of P. So step number 1, where do we find P? We can see that P is on the x-axis. And then along the x-axis, we know that y is a 0. So since P is a point where F and G are passing, we can't use F because we have some unknowns, but we can apply G since we know the equation. So where there is y, I'll put a 0. So 0 is equal to x plus 4. Move the x that side, which means it's -4. So which means P is -4 and 0. Then 6.2, hence or otherwise, write down the coordinates of Q. So for me to get the coordinates of Q, I know that this -1 is just a midpoint. Okay, it's just halfway between. So if this is a -4, how many units am I moving here? These are 3 units, which means I must also move 3 units that side. So -1 plus 3 is going to be a +2. So I'll have 2 and 0. Should be 2 mass. Yeah. Then they want the average gradient between P and R. This is P, this is R. So for average gradient, just use the normal gradient formula. Changing y over changing x. Or y2 minus y1 over x2 minus x1. So if our y2 is a 9, minus the y1 is a 0, over my x2 is a -1, minus -4. So if we simplify that, we're going to have 9 over 3, which means our gradient becomes a 3. Then 6.4, can we show that A is -1, B is -2, and then C is 8? Show all the workings. Now, this question comes with lots of options to use. Okay, so which options are those? We can choose maybe the intercept, or we can also use the turning point method. So if I use the intercept, okay, should I use the intercept? Yeah, I can use the intercept, where I say y is a, x minus x1, x minus x2. So a into, we have x minus -4, which is going to be x plus 4. And then this is going to be x minus 2. Okay. Then for me to get the value of a, can replace x with a -1 and then y with a 9. Okay, just any point along the parabola. other than these ones that I've used. And so 9 is equal to a into negative 1 plus 4 into negative 1 minus 2. So that's going to be a 3. It's going to be a negative 3, which means I have negative 9a is equal to 9, which means my a is a negative 1. All right, so having obtained that, I just need to do the substitution. So y is negative 1 into, we can open that up, so it's x squared from this label, minus 2x plus 4x minus 8. So y is going to be negative x squared. That's going to be a positive 2x. Then when you introduce the negatives, negative 2x plus 8. So that becomes our f. But then the question was not asking for that. The question was asking us to show that, proof. So we can see that our a is negative 1, is the b negative 2, correct? And then the c is 8. All right. So that is how we would have approached that question. Then calculate the coordinates of S, the point of intersection of the two. So when two graphs meet, okay, the graphs will be equal to each other. So it's as good as getting f of x and then equate it to g of x. So when you solve this, we can see that the graphs are meeting at 2 points, which means we shall end up with 2 answers. All right, let's see. So we're going to say negative. We're saying f of x is equal to g of x. So negative x squared minus 2x plus 8 is equal to x plus 4. Let's create a standard equation. So it's negative x squared minus 3x. That's going to be plus 4 is equal to 0. If you choose to divide through by a negative, it's going to be x squared plus 3x minus 4 is 0. Having this, we shall have x and x and have a 1 and a 4. Plus and a negative. So which means x is either a 1 or x is a negative 4. But we already know that x is a negative 4 at p. So this is going to be the s, the positive 1. Okay. Then substitute this into the equation of x plus 4, which means y is a 5. So s is going to be 1 and 5. All right. So that is question 6.5. Then determine the maximum length of TV between the points. So whenever we find distance between two graphs, you just need to subtract the two equations. Okay. Remember, they're asking for maximum. So if I get f and then subtract g, so f of x minus the g of x. So if I do what I just did, I think I'll end up with more or less the same thing, which is going to be the x squared, okay, plus 3x minus 4. But now they're asking for the maximum. If it's maximum or minimum, you use the turning point method, minus b over 2a. So this is representing the distance between the graphs at any one point. So if you equate it to 0, that's when the graphs are meeting. Okay, so I'm not equating it to anything so that I can get a value there. So our b is a 3, so negative 3 over 2 times 1. What did I do? What did I do? What did I do? What did I do? I messed it up again. Let me use the original and not this simplified one, because the original was negative. Okay, so the original is negative x squared minus 3x plus 4. So which means a negative, which is a plus over negative 2, and then that. So which means our maximum is at a point where x is a 3 over 2 negative. Then I'm going to substitute this into this expression. So negative 3 over 2 squared minus 3 into negative 3 over 2 plus a 4. With the help of a calculator, okay, I'll have that plus 9 over 4 and then plus 4. So I'll have just 4 units. That's when we shall have the maximum. In other words, the maximum distance between the 2 points or the 2 graphs can only be 4. Then determine the values of x for which x multiplied by f of x is less than 0. X multiplied by f of x is less than 0. So what this question is just asking for is that when we look at f, okay, f is the parabola. And then this x is going to represent any side on the x-axis, either on the positive or the negative. Now, if we have just x as a positive, which means g must be negative for us to have this condition. Or we can look at x on the negative side, but then we look at f of x being above the x-axis, okay, on the positive side. All right, so let me look at the first condition. Where do I find on the positive x-axis? Okay, on the positive x-axis, the graph of f to be negative, to be below. So it is from this point to that end. Okay, so I'm going to say x is greater than 2. Then on the negative side, now I'm focusing on the negative. Where do I find on the negative x where the graph of f is above? Okay, so it's above between this negative 4 and then between this 0 itself. The graph is still above the x-axis. Okay, I cannot go or stretch much into that side because we've already seen. Because we said we're looking at the negative axis. So we're going to say negative 4 is less x is less 0. So this and that will give us the 3 marks. Now, it doesn't end there. Sometimes even this question could be brought in the form of x over f of x is less than 0. So the idea still stays the same. This can be a positive and a negative. This can be a negative and still a positive. So regardless of how it comes, the approach should be just the same. All right, 7.1, which is the finance. We're telling us that the value of a laptop depreciates, okay? Depreciate is lose value on a reducing balance. That's the key word. At a rate of this, calculate the original value of the laptop if it had depreciated this over a period of 5 years. So we need to know what reducing balance formula is, and we know from our formula page that it is 1 minus I to the exponent of n. If it was straight line depreciation, then that is the p into 1 minus in, okay? Okay, so we're seeing they want us to get the original, which is the p. So for us to get the p, it will be a over 1 minus I to the exponent of n. So the final value or the book value is 7,210 over 1 minus, that's going to be 13.4% to the exponent of how many years? It was 5 years. And then we just punch this into our calculator. So 7,210, okay, over 1 minus 13.4% to the exponent of 5. So that's giving me 14,802.87 rands. So this is the original price. Now, before I leave this question, you saw that in the metric papers, they no longer give candidates such questions with direct values or direct numbers, okay? The terminologies are changing whereby instead of talking about a particular value, they use fractions. That let's say the amount depreciated to half the original, the amount depreciated to 0, the amount depreciated to a third, something of that nature. So if they don't give you an amount, let's say your amount is P, okay, this is the original. So which means the final value, if you're talking of maybe a third or a quarter or even 3/4, okay, which means it's a quarter P. And then if they give the interest rate of, let's say, 10%, and then they, in this case, they will not ask for the I, but in this case, they will be Okay, they can ask for the I, and then they give you the period. Okay, determine the I. If the period is maybe 8 years, 7 years, blah, 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 blah. So it's just going to be the same thing. What fails most learners is interpreting this, and there's no amount. What do we do next? Just apply any letters of your choice or even any numbers of your choice. Get an amount and then apply the relevant condition that they gave you. All right, then 7.2, calculate the effective interest rate if an investment offers a nominal interest rate of this compounded quarterly. So we know that from our formula, 1 plus I effective should give us 1 plus I am over n to the exponent of n for the nominal. Then 1 plus the I effective is equivalent to 1 plus, this is going to be 8.2% compounded quarterly. I'll say 0.082 over 4 to the exponent of 4. Then I need to move the one that side for me to get my I effective. So it's going to be 1 plus 0.082 over 4 to the exponent 4 minus 1. The answer I get whenever I have to look for the interest rate, I have to multiply by 100. So that's going to be 1 plus 8.2% over 4 to the exponent of 4 minus 1. And I multiply by 100, that should give us 8.46%. Now, these values in most cases will always be close to each other. Remember, the nominal was 8.2. This is 8.4. If the other one is 9.5, probably the other one should be 9.6, so something of the sort. All right, 7.3. Alan invested an amount of 20,000 on the 1st of January 2015 at an interest rate of this compounded monthly. At the start of the second year, he deposited 15,000 into the same account, but the interest rate increased to this compounded monthly. At the end of the third year, he withdrew a certain amount from their savings and kept the rest in the account for a further 2 years at this interest rate, compounded quarterly. So what was the balance of the investment on the 31st of December 2015? So 31st December, that is after 1 year. So let's see. This is going to be more of a timeline. Okay. So this is the 1st of January 2015. There was, you can say 20,000 invested. Then after 1 year, okay, they said at the start of the second year. So from there up to there is 1 year. Then at the start of the second year, there was a 15,000 that was invested again, but then the interest rate changed because this is now 11.5. This was 10.3. Okay, then at the end of the third year, this person withdrew some money and kept the rest for a further 2 years. So which means we're going to have a maximum of 5 years. So it's 0, 1, 2, 3, and even have 4, no problem. So January, at the start of the second year. So why am I having that much? Let me just call this a 5. So if this is the start of the first year, that's 1st of January, then this is the start of the second year, the third, the fourth, and that is going to be the final year. Okay, so what's the balance? December 2015. So this amount would have grown at a rate of 10.3 for a period of just 1 year. So I'll use my normal compound and say A is equal to P into 1 plus I to the exponent of A. Then it was a 20,000 into 1 plus, it's going to be 10.3%, or you can give it as a 0.103. Okay, compounded monthly to the exponent of 12. Then we just punch this, so 20 tau into 1 plus 10.3% compounded monthly to the exponent of just 12 months. That's going to be 22160, comma. But is it even 12 months? Because they said, okay, what's the balance? On the 31st. Yeah, that's 12 months. Because now 1st of January, that will be something else. It will be a new year. Okay, comma 09. Okay, so that's what we shall have in the account. Then how much to the nearest round did the person withdraw at the end of the 3rd year? At the end of the 3rd year. So the end of the 3rd year is more like the beginning of the 4th year, somewhere there. So if there's an X amount that was withdrawn, so I'll look at the 20,000 that grew to that. That was a deposit of 15,000, which means I need to plus the 15,000 in this case. So 22160,09 plus the 15,000. Okay. So that's going to give me something like 37,160,09. Then this amount must grow at a rate that has been stipulated. Okay. So the rate that they gave us was 11.5% monthly. Then at the end of the 3rd year, not at the beginning. So which means it's going to grow from the 2nd year to just the 3rd year, and then the 4th year. Those are 2 years. All right, so I'm going to make it grow from the same formula. So it's going to be 37,160,09 into 1 plus the interest rate is 11.5% to the exponent of 12 times 2. All right, so if I punch that into our calculator, we said 11.5% over 12 to the exponent of that much. We shall have 46718,50. So this is what we're going to have at the end of the 3rd year. All right. Then there was a withdrawal of an amount, which is X. Okay, and then whatever remains must grow at 16.8 compounded quarterly. So which means just going to grow for 1 full year. Okay, the end of the 3rd year. Start of the 2nd year. So the end of the 3rd year, we have the end of the 4th year and the end of the 5th year, which is also going to be the 2 years. So which means it's going to be the 46718,50 minus X into 1 plus, that was 16.8% compounded quarterly into 2 times 4. All right, so this must give us an answer of 3183,64. So let's divide both sides by this bracket here. I think that will be quicker. So 3183,64 divided by this bracket. We shall have 46718,50 minus X. So let's see if we're going to get an answer. Guys, remember this is just an idea of how the question would be approached. Do not necessarily look at how accurate it is, but we just have an idea of what would be going on. So I'm getting 2-1. 718, comma 50 is equal to 46718, comma 50 minus x. When I move this one that side, it's going to be subtraction 46718,50. So I'm ending up with a negative 24,999. But then why am I having that? Because that will cancel out. The 21718,50. 46718,50. That's giving me 25,000. Okay, so 25,000 is equal to negative x. So which means the amount that this person withdrew was just 25,000 rands. Guys, that is just the idea or the concept. So there are always also simpler ways of doing it. Feel free to use them. That is question number 7, the finals. Question number 8, which is probability, telling us that a bag that is containing 3 red and then 5 yellow. Okay. Then suppose a player picks a ball at random, observes the color, and then does not replace it. He then picks another. Can we draw a tree diagram to show all the possibilities as well as the probabilities? So I think I can slot it here and say that if the first ball is red, the second one can be yellow. If it's a red, that's going to be 3/8. This is going to be 5/8. If the first one was a red, which means the reds are going to decrease in number. So it's going to be 2/7 if the first one was a red. The yellows will still stay intact, which is a 5/7. Then here, if it's a red, it will stay 3/7. This would be a yellow, which is 4/7. So we have a red, a red, yellow, a yellow, red, and then a yellow, yellow. So those are the outcomes. Then determine the probability that a player picks balls of different colors. So it's possible for you to get a red and yellow or a yellow and red. Now for us to get the probabilities, the first red is 3/8 multiplied by the yellow, which is 5/7, plus the first yellow is 5/8 times the red, which is 3/7. So that's 15/56. That's 8 times 7 is 56. So 15/56, that's going to be 30/56. Please and please, you simplify that. That becomes 15/28. Okay, 15/28. So give it as a fraction, common fraction, give it as a decimal, or even as a percentage, shall still be fine with it. 8.2, the probability that South Africa reaches the finals of 2019 World Cup is 0.35. Probability that New Zealand reaches the finals is 0.5. Probability that neither reaches is 0.06. Draw a Venn diagram. So these are just 2 events. Okay. It's either South Africa, okay, I'll use S, and then N for New Zealand. Why am I using Z? Let's use N. Okay, so we know that the sample space here should be not 0.1, it must be just a 1. Okay, because the total probability should be a 1. So neither is 0.06. Okay. So the probability that South Africa reaches the final is 0.35. Okay, that's 0.35. Probability New Zealand reaches is 0.5. And then neither. So if this is X, it's going to be 0.35 minus X, 0.5 minus X. Then determine the probability that both, which means we need to solve for X. All right, so that is 8.2.2. So for us to solve for X, just add up everything and then equate it to 1. So 0.35 minus X plus that X plus the 0.5 minus X plus the 0.06 must give us a 1 as the total probability. So when I add up all these numbers, I have 0.35 plus 0.5 plus 0.06. That gives me 0.91. This cancels that. Have minus x is equal to 1. Did we do anything wrong? So 0.35, 0.5, 0.06. Okay, so then you can move the x around and then get the answer. But why am I getting a negative, guys? Is the question fine? Probability that it reaches this. Probability that reaches is that. Probability that neither, no, is 0.06. Okay, so that's what I'm getting. That's what I'm getting, because now I'm going to end up with a negative answer, which will not make sense. That is 0.09, which is not going to make sense for probabilities. Okay, but with a question, that would be, or that would have been the approach. Okay. All right, then now question number 9, which is the two-way table. I think before I leave question 8, I'll probably also advise people to also look at those formulas of independent events, okay, independent events, and then dependent events, and also what we call the mutually exclusive with the probability rules of A or B. Okay, probability of A plus the probability of B minus the probability of A and B. Just know how to work around with this, because sometimes it can give you the probability of A, can give you the probability of B, and then they give the probability of A or B, and then they ask for AND, given the conditions, whether they are independent or mutually exclusive. All right, so the two-way table, partially completed table, shows the number of distinctions that were obtained by male and female learners in a particular district in 3 subjects: maths, accounting, and physical sciences. Determine the value of A and B. So what we know about this is that the columns and the rows must always add up to that. Okay, so for us to get A, we know that A plus 81 must give us 164. So for us to get our A, it's 164 minus 81. So what is that? Is it 83? 164 minus 81, that is 83. So A becomes 83. Then with B, you can add this 83 and the 97. Or you can subtract 260 from the 500. Either way. Okay, you still get the same thing, which is a 240. So B becomes a 240. All right, the 9.2, we love the 9.2 a lot. So use the information table to determine if the events male obtains a distinction in maths and F is a female are independent. Okay, so remember the table is talking about the number of distinctions. Okay, so in this case, we have to go to the formula of the independence, where we talk about male with a distinction and then female. Oh, it's a male with a distinction in maths. So let me use MM. So this should be the same as a male with a distinction in maths multiplied by the probability of just female, whether you have a distinction or not. But does this make sense? No, it's not a male, guys. It's a learner that obtains a distinction in maths. Ish, man. It seems like I'm tired, ne? It's a distinction in maths and then a female. So distinction in maths as well as the female. I was wondering, okay. So a learner that obtains a distinction in maths and then F is just a female. So how many learners obtain a distinction in maths? Just how many learners? That's what we are looking at. Okay, so we have 125 learners that obtain a distinction in maths, whether they are male or female. That is overall, which means the probability of M is going to be 125. Okay. Then we've seen that the females, we have 260. So this is going to work on this other side. Then females that have distinctions are 65. So on the left-hand side, distinction with the females is going to be 65 over 500. How many distinctions are there? We said it's 125 over 500. And then how many females are there? It's 260 over 500. Then all I'll do, I'll simplify. So if I look at the left-hand side and then simplify that, I'm getting 13 over 100. When I look at the right-hand side, so 125 over 500 multiplied by 260 over 500. That is giving me 13 over 100. Now, I can see that the left-hand side and the right-hand side are equal to each other. Alternatively, you can just use decimals, okay? 0.13 is equal to 0.13. So if this scenario pops up, then we can conclude that the events are independent. So therefore, the events are independent. Events are independent. If the sides are different, then the events will be dependent, or they will not be independent. All right, the 9.3. If a learner is selected at random, calculate the probability that the learner is a female who achieved a distinction in maths or physical sciences. A learner is a female. Okay, that's the first condition. It has to be a female who obtained a distinction in physical sciences and maths. So how many females obtain distinction in maths? We have 65. In the physical sciences, it's 114. These girls are serious, no? So it's going to be 65 plus 114. That's what we need since we're looking at two subjects. So 114 plus 65 is 179. Then since we're talking about probability, you divide by the total. So 179 divided by 500, we get 0.358, which is 0.36. Leave it as a fraction, simplified fraction, or just a decimal. There is no problem. Or even a percentage. So you'll get your marks for that. So guys, we've come to the end of the proposed paper. But remember, in this paper, you'll always be given a formula page that you can always consult, in as much as not all formulas will be there, but at least majority of them, okay? So I just wish you all the best. Please just do your preparations. Try to manage your time as far as possible. Paper is 150 marks, and the time is 3 hours, which is 180. So literally speaking, we have like a minute and a fraction of another of a minute. So what I usually advise learners is just look at it as 1 mark and one minute. Okay, so that whatever is left is just extra for you to just focus on the gaps that you've left and then confirming your answers. Okay. Feel free to start with any question that you feel comfortable with, because in that way you're going to save quite a lot of time. Start with sections where you are very confident, and don't drag or dwell too much in a section that is draining you, where you waste quite a lot of time. Okay. So having said that,